Welcome back to Hard Problems Made Easy. Today we are going to look at n queens problem. So the problem statement is that we are given a number n, right? So this number represents an n cross n chessboard in which we have to place n queens in such a way that none of the queens fall into the attack span of the other queens. Look at this example here. So we have a queen here. So it has 8 directions in which it can go and attack, right? So the left, right, top, down, and the diagonals, right? So in any of these 8 directions, there won't be another queen. So for all of these, right? So the answer that we have to return is we have to return all the result boards in this fashion, right? So the first answer is like the first row is dot queen dot dot. This is the first row, and so there are these two answers for n equals 4, and that is what is being returned here. Okay, so this is the problem statement. Now let's look at the simulation. Our solution will be a backtracking solution because we do not have any overlapping subproblems here. I think it will be apparent if we go into the program. Essentially, we are looking at trying all the possibilities because there is no overlapping subproblem for the given states in this problem. Right? So that is why a backtracking algorithm. Look at our backtracking solution. So the first consideration is that we put queen 1 in the very first cell that we have, and her span goes in both the diagonals as well as horizontally and vertically. So that means the next queens that we are going to place should not be in any of these pink boxes, right? So what would be the next possibility then? The queen 2 can go here or here. We'll go in order, right? So the queen 2 again, if you look at her span, whatever were the other boxes um, that were not occupied by the pink boxes, I put them as green boxes. So we have queen 2 span here, right? Now, at this point, should we look at taking queen 3 and placing her here? We shouldn't, because it is the nature of the problem, right? So the nature of the problem is that each row will have to have one queen because this is an n cross n matrix and we have n queens, and we can't afford to have an entire row without any queens. So this is where we will stop proceeding with the tree and then start to backtrack. So this is not a solution. So we go and backtrack. Previously the queen 2 was here. We'll try this possibility, like the next possibility for queen 2. Now here we have these two possible, queen 2 again. We've seen her span now. We will look at placing the only possibility queen 3 here. Now queen 3 has again occupied the only white box that was supposed to be here for queen 4. So this is not a valid solution. So we move and backtrack. So we put queen 1 in the next one. Here we have only one possibility for queen 2. Okay, so this is her span. So there is again only one possibility here for queen 3. Now we have one empty box, which means this becomes a valid solution, right? For all 4 queens, do not interfere with each other's attack surface, right? So this is the one solution. So we keep moving, we backtrack, keep queen in the third grid, queen 2, queen 3, again another valid solution, backtrack, next possibility. So queen 2 has two possibilities. We'll try them one by one. Nope, no space for queen 4. We backtrack and see if queen 2 being here helps. This is not a valid solution. Place queen 2 here. Nope, because the third row is already filled up. And then the solution is completed. Let me go one step back, right? So now the queen 1 has traveled here, 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 here. And after that, like, usually in backtracking solutions, or like, we get to keep going to the next row, right? But here, like, each queen needs a row. That means the program is complete at this point, right? So we have two solutions and we are going to return the answer. So now let's look at the code. But before we go to the code, right, let's look at how we are bookkeeping, the state of what we have here. Okay. Now let's look at what these sets are. The set is basically like whatever I've showed in color here, right? So when we are considering placing queen 2, we have to make sure we don't place it here or here. To know that, we keep set, each of these are sets. There's a row set, there's a column set, there's a diagonal 1 set, and there's a diagonal 2 set. So each of these, row and column, is pretty simple, right? So we go here, we know that this particular column is already occupied by queen 1, so we shouldn't go here. But what about these diagonals? How are they stored? So basically the diagonal is either r minus c or r plus c, right? So let me like, go next, and maybe we can understand with a better example. Okay, here this is queen 2. Queen 2 sits in 1 comma 2, right? Row is 1 and column is 2, and the diagonal one is 1 minus 2, which is minus 1. So in each of these boxes, if you do this calculation of row minus column, you will always get minus 1 in each of these three boxes. Similarly, for diagonal 2, we always have to add them, and the sum of the row and column will always be 3 for this diagonal. This way, we can easily store the state of the system as we proceed with our solution, and also reverse it when we are doing the backtracking. Now, this does not work, right? So now we will remove these from the set. We'll remove these from the set and keep only the span of the queen 1, and then like move queen 2 to the next one. Now this, like, we have the row, column, diagonal 1, diagonal 2, which helps with looking at where to assign queen 3 and queen 4. That is what these sets are all about. If we walk through the code, I think we'll be like easily able to understand what's going on. We have initializing a result. We are initializing the board with dots initially, and in case we find a placement for a queen, we make it q. Okay, and in case we find that we have spanned through all the rows, that means we have a solution. We haven't stopped anywhere and we have a solution. So we return the current state of the board. I mean, we append the current state of the board to the result list. Okay, so instead of having it as a 2D matrix, we have it as a list of strings, which is what is expected output here. Okay, so we have seen, like, what this part of the code does. Now we will go for, what this for loop is doing, right? So this for loop is essentially whatever are the white boxes per row that we see, right? For example, we go here, right? So we go, let's take this example, right? So for queen 1, we have to go column wise. For queen 3, we have to go column wise. We have to test each and every column as we span through the rows, and that is what is, this column range, right? So, and now we are going to see whether they are part of the set here, right? So there is a row set, there is a column, there's a diagonal 1, there's diagonal 2. Now the row is not needed as a set because anyway we are spanning through the row one by one in our backtracking solution. So we are only seeing whether it is part of the columns and whether it is part of the diagonal 1 and diagonal 2. If it's already there, that means it is a colored cell and we are not allowed to place a queen there. Otherwise, we proceed and place the queen there and then add the span of the queen to the column diagonal 1 and diagonal 2, and after that we move to the next row. Okay, we backtrack, move to the next row. So the state here is global. Okay, so we move to the next row, and if we keep moving to the next rows, and if it has reached the bound, then that means we have a solution. Okay, and after that, whether or not we get a solution, like we anyway go through these steps of backtracking. Here it is about proceeding, here it is about backtracking. Okay, we mark it back to dot. Okay, and then we remove the span of the queen, like the column diagonal 1, diagonal 2. So as and when there are valid solutions, it gets added to the result, and finally the result is returned. This is where the program execution is, of course. And we just have to do backtrack of 0, and which means like we are doing only the backtrack. We start the backtracking only at this row 0, and within this row 0 there's going to be a for loop for each of the columns here, right? So let me reset the program, right? So we start with this row 0, and then this queen is going to look at all the span below, move here, move here, move here, and that's it, end of the program, right? So that is the overall solution. Hope this was helpful. See you in another video. Thank you.